Good afternoon, everyone. Myself Punnam. I am working as a assistant professor in a EEE department, Mlritm. Today, I am going to explain the concept of signal flow graph. Last class, we discussed the block diagram reduction techniques. So, the presentation outline is a signal flow graph technique or SFG. It is also called as SFG. Block diagram to a signal flow graph conversion, and calculating a transfer function using mass and gain formula, and few problems. So signal flow graph is a graphical representation of a relationship between the system variable. The signal flow graph does not require any reduction because there is a graph gain formula which is directly gives the transfer function. It was developed by Dr. S.J. Mawson. The signal flow graph can be obtained from the block diagram of the system. Signal flow graph can also be obtained from the system equation directly. The equation must be an algebraic form, that is in S domain, and it is applicable only for a linear system or LTI system. So the components of a signal flow graph, basic components are node. So node is defined as a point representing a variable or a signal. There are three types of nodes. One is input node, output node, and mixed node. Source node or input node. So node with only outgoing branches is called as source node or input node. Sink node or output node, the node with only incoming branches. The components of a signal flow graph, mixed node. So it is a node which has both incoming as well as outgoing branches like this. So different incoming branches will be there and different outgoing branches will be there. So these kind of nodes are called as mixed nodes. Next, branch is defined as a line segment which joins two nodes. It has both gain and direction. The signal passes through a branch gets multiplied by its gain. Components of a signal flow. Let us consider a flow following signal flow graph. Identify these nodes and branches. So see here, there are y1, y2 and y3, y4 are the nodes. The nodes representing the signal flow graph is y1, y2, y3 and y4. And a, b, c, d are the branches of a graph. So we can also call as branches are a gains of a graph. So path is defined as it is the route of connected branches in the direction of branch arrows. So see here, this is a path. It is a connected branch consisting of direction. So this is a path. It is a path. It is the route of connected branches in the direction of branch arrows. The direction of branch arrows. Open path. The path starts at one node and ends at another node. Next, forward path. A path starts at input node and it ends at output node. So in this case, in this example, this is a starting point or a starting node. From this node to the signal is traveling from input node to output node through a path through this arrow direction. Next definition is closed loop or closed path. A path which starts and ends at the same point is called as closed path. So see here, the signal is starting from this point and it is going like this and like this, and at the same point. So it is called as closed path or a loop. So loop gain is equal to gain is equal to G1 into G2, product of forward path gain and the feedback gain. So that is G1 into G2. And non-touching loops. These are the two loops which is not having a common node. Non-touching loops means the loops which does not have any common nodes. So see here. So this is a loop and this is another loop. This is not having any common node. This is not having any common node. This is called as non-touching loops. Next, block diagram versus a signal flow graph. We can represent a block diagram with a signal flow graph. In this example, see here. So block diagram which is having a block which is having a input R of S and output C of S, and G of S is the gain. So we can represent this block diagram in a signal flow graph like this. And the signal is traveling from input node to output node. So arrow has to decide from left to right, from input to output. So this is R of S is the input and C of S is output, and G of S is gain of a block. And see another example. It is a feedback network. So this is a input and this is output. This is forward path gain, and this is a feedback network, H of S. So now when signal is traveling from input to output, the output may not be getting accurate. So for that, what we have to do to get the output as accurate, we have to use a feedback network. So the feedback network will compare the input signal with the existing output. So it will generate a error signal. So this error signal is passed through a controller, and the controller will generate the proportionate error quantity, and the output is rectified. Okay, so this feedback path can be represented as this is in a signal flow graph. This is input node and this is output node, and this is a summing point. So this is a forward path gain which is having node 1, and this is a forward path gain, another forward path gain. So this G of S is represented here, and this is a forward path gain. So, and this is a feedback network H of S. So block diagram can be represented in a signal flow graph easily. So next, signal flow graph using system equation. Let us construct a signal flow graph by considering the following algebraic equation. So here y2 is equal to a1 to y1 plus a4 to y4 is equation 1, and equation 3 is a23 y2 plus a53 y5, this is equation 2, and equation 4 is a34 y3, and this is equation 3, and so on so forth. There will be a 6 nodes y1 y2 y3 y4 and so on y6, and the 8 branches in the signal flow graph. The gain of the branches are a12, a23, a34, 45, 56, 42, 53 and 35. Let's see how to construct signal flow graph. So to get the overall signal flow graph, draw a signal flow graph for each equation and then combine all this equation graphically. Okay, step 1, the signal flow graph for first equation, that is y2 is equal to a12 y1 plus a42 y4 is shown below. So see, so this is first node y1, y2, y3, y4, y6, y5 and y6 so on. So I am taking all the nodes, all the 6 nodes, and first equation I am writing equation at y2. So here there are 2 signals are entering. First one is this, and second one is this signal. So this signal. So I have to write the gain product of gains. So A12 into Y1. Y1 is input signal is multiplied with the gain, forward path gain A1 to Y1 plus Y4 into A4 to Y4. This is my first equation, or second equation. It is given first equation. First equation, y2 is equal to a12 y1 plus a42 y4. Okay. Next step. Second equation is y3 is equal to a23 y2 plus a53 y5. So see, I am considering at node 3, there are two signals are entering. First signal is this and second signal is this. So first signal is a y2 is multiplied with gain product, gain a21. So y3 is equal to a23 into y2 plus, and another signal is also entering here, that is y5 is multiplied with the gain a53 into y5. That's it. And next, third equation is that y4 is equal to a34 y3. a34 y3. So see, at node 4, only one signal is entering, that is y3, and it is multiplied with a forward path gain a34. So this is the graph for this equation. Next, fifth equation, that is given y5 is equal to a45 into y4. So at node 5, I am considering there are two signals are entering, which is y4 and y3. Okay, so the net or y5 is equal to product of gain product of y45 into y4 plus y3 into a35 forward path gain. Okay, so this is how we have to represent, or we have to draw a signal flow graph. Next, last equation, that is y6 is equal to a56 into y5 as shown in figure C. So I am considering at node 6. So there is only one signal entering, that is y5. It is multiplied with the a56. a56 is multiplied with the a5. So this is how we can draw a signal flow graph using system equation. So now overall transfer function is given. If I combine all the equations in a single graph, the graph will become like this. The graph will becomes like this. So if I consider the number of forward paths, in this case, this is one forward path and this is another forward path. Okay, that's it. So there are two forward paths in a given graph. Next, most important concept is mass and gain formula. So mass and gain formula is to find the overall gain of a signal flow graph, which is a overall transfer function of a system. So overall transfer function of a system is given by a sigma k is equal to 1 to n p suffix k delta k by delta, where tf is the overall transfer function of a system, pk kth forward path of a transfer function, and k is the number of forward paths in the graph, and delta is determinant of a graph, and delta k, the value of delta for the part of a graph not touching the kth forward path. So this is a mass and gain formula which is very much useful to redact a block diagram as well as signal flow graphs. So delta is equal to 1 minus sum of individual loops gains plus sum of individual product of a two non-touching loops minus and so on so forth. So first one is sum of individual loop gains, 1 minus sum of individual loop gains plus sum of gain product of two non-touching loops and then three non-touching loops, then four non-touching loops, etc. plus and so on. And delta k is equal to 1 minus sum of gain which not touching the kth forward path. Delta k is 1 minus sum of loop gains which are not touching the kth forward path will give you delta k. Next, let us consider one example. So see in this graph, so calculate the forward path gain, forward path transfer function pk for each forward path k. So let's first identify the what is input, what is output for this system. So this is a input node, this is input node, and y of s is the output node. So signal is traveling from input to output. So ratio of output by input is called as transfer function. Laplace transform of output to the Laplace transform of input with all initial conditions equal to 0. This is called as transfer function. So let's identify the forward paths in a given graph. So see, there are two forward paths. One is G1. Forward path means the signal must travel from input node to the output node, no reverse. So the signal is traveling like this: G1 and G2 through G2 and G3, G4, and finally it reaches the output. And another forward path is G5 into G6 into G7 into G8. This is another forward path. Now I have to identify number of loops in this. So see, there are total 4 loops. First one is G2 into H2, loop 1, and this is another loop. Loop means the signal should start at a node and it must end at the same node. So this is another loop, G3 into H3, and third loop is G6 H6, and fourth loop is G7 H7. So there are 4 loops: G2 H2, G3 H3, G6 H6, and G7 H7. Considering non-touching loops at a time. So see, there are total 4 loops, and the non-touching loops are, one loop should not touch with the another loop, means it should not share the common node with another loop. Okay, so let's start. Loop 1 is not touching loop 3 and 4. See, this loop is not sharing any common node with loop 3 and loop 4. So one non-touching loop. And loop 2, consider loop 2 is do not touch any loop L3 and L4. See, this L2 loop is not touching L3 and L4. Okay, so let's write the transfer function. So we know that transfer function is sigma k is equal to 1 to n pk delta k by delta. So first of all, k I have to identify. K is the number of forward paths. I am having 2 forward paths. So I have to rewrite the transfer function formula, that is P1 delta 1 plus P2 delta 2 by delta. Now calculating a delta value. So delta value is, as I told you earlier, 1 minus sum of individual loop gains plus sum of two non-touching loop gains. So this is one non-touching loop gain, another 2, 3, 4. There are 4 non-touching loops. See, this L3, L1 is not touching to L3, L4, right? So I have to take the gain product L1, L3 and L1, L4. L1, L3 and L1, L4. L1, L3 and L1, L4, right? And next L2 is not touching to L3 and L4. So L2, L3, L2, L4. L2, L2, L3 and L2, L4. Clear? Now calculating the delta K for each forward path. See, so forward path, there are 2 forward paths are there. So I have to calculate delta K. So delta K, delta 1, first of all, first forward path I am considering, delta 1 is equal to 1 minus L3 plus L4. Why I am writing this L3, L4? Because the formula is that 1 minus sum of loop gains which are not touching to the kth forward path, right? So L3 and L4 are not touching to the first forward path, no? For this forward path, the L3 and L4 are not touching. So delta 1 is equal to 1 minus L3 plus L4. Next, now I have to calculate delta 2. So delta 2 is same, 1 minus sum of loop gains which are not touching to that particular forward path, means second forward path. So see, in this case L1, L2 loops are not touching a forward path 2. So the equation is delta 2 is equal to 1 minus L1 plus L2. Clear? So finally the transfer function is P1 that is P1 equal to what? G1, G2, G3, G4. G1, G2, G3, G4 into 1 minus L3 minus L4. L3, L4 means I have to write L3 and L4 means this gains I have to write there. L3 and L4 over here. Okay. And next second forward path is L5, G5, G6, G7, G8. G5, G6, G7, G8 into 1 minus L1 minus L2. L1 minus L2. Okay. So what is L1? L1 is first loop gain, that is G2, H2, and L2 is G3, H3. I have to write over here. Next, by 1 minus delta. This delta is equal to, what is the formula for delta? 1 minus sum of individual loop gains plus sum of gain product of two non-touching loops and so on so forth, 3, 4, 5, etc. So 1 minus sum of loop gains. Individual loop gains are 1, 2, 3, 4. There are 4 loops are there. So I am writing those loop gains, that is L1 plus L2 plus L3 plus L4. Okay. Next, sum of non-touching loops. Non-touching loops are there are 4 non-touching loops. L1, L3, L1, L4, L2, L3 and L2, L4. So I have to write here the all loop gains, and then finally that is the transfer function of a given signal flow graph. Next, same thing I have explained here. So let's solve another example. So this is a given signal flow graph and I have to find the transfer function. So first of all, observe what is input for it, what is the output node. I have to find that what is the input node, U is the input node and output is Y. Okay. So next what I have to do, I have to identify the forward paths. So how many forward paths are there? Forward path means signal must travel from input to output. So this is one forward path. Okay. And this is second forward path. The arrow symbol we have to consider properly. So P1 is G1, G2, G3, G4 and P2 is 1 into G5. So there are 2 forward paths. And now loops. loops are, first one is L1. See here, so this loop is starting at this point and again ending at the same point. So it is a loop. Okay. So now this is loop 1. And L2, consider this is L2 G3 on, this is not a loop. This is not a loop. And yes, this is a loop. This arrow direction is for this loop. Okay. So G3 and minus H2 is a loop 2. This is L1 and this is L2. And see here, the signal is traveling from this and again it entering at the same, ending at the same. So this is L3. So G4 H3 minus G4 into H3. Now two non-touching loops I have to consider. So see, L1 is not touching L2 and L3 both. So L1, L2 is a first non-touching loop and L1, L3 is the another non-touching loops. So finally, the formula is sigma k is equal to 1 to n delta pk delta k by delta. So P1 delta 1 plus P2 delta 2 by delta. So what is delta 1? So delta 1 is 1 minus the loop gain of a forward, which is loop gain of forward path non-touching loop. Let's see. So see, I have to find delta 1, no? Okay, let's move on. Okay, see. So delta 1, see here, delta 1 is 1 because all the loops are on the same forward path, first forward path. So delta 1 is equal to 1 minus loop gains, but 1 minus 0 no need to write. So delta 1 is equal to 1. Next, delta 2, see here, delta 2 is, this is the forward path, but there are three loops are there. Which two loops are loop 1 and loop 2 are not sharing any, not touching to the forward path. So that is the reason 1 minus H1 minus G3 H2. So minus into minus plus, it will become 1 plus H1 plus G3 H2. So this is another forward path delta 2. Okay. Now finally, so this is P1 is G1, G2, G3, G4, G1, G2, G3, G4, and delta 1 is 1 plus P2 is G5 plus multiply into delta 2 is this 1 plus H1 plus G3 H2, 1 plus H1 G3 H2, complete numerator. Okay, come back to the denominator. What is the denominator? 1 minus delta is 1 minus sum of individual loop gains and sum of two non-touching loops and three non-touching loops. There is no three non-touching loops, only two non-touching loops. The two non-touching loops are there. So 1 minus H1, first loop gain, sum of first loop gain, second and third. So H1 plus G3 H2 plus G4 H3 plus two non-touching loops. Two non-touching loops means L1 L2 and L1 L3. Okay, so this is L1 L2 and L1 L3. Okay, finally this is the answer for given signal flow graph. Thank you very much.